Okay, so today we're going to talk about something called recursion. Recursion means look at what's already happened, do something to it to get the next thing. When I used to teach an integrated math program, we used to call it the now and the next. What's happening right now, what's going to happen next. So I'll kind of refer to it in both ways. And we need to know some vocabulary to get started. And so a sequence is a list of numbers separated by commas. For example, 1, 7, 12, 25. A term of a sequence is a specific number in the sequence. For example, number 12. And the general term of a sequence is the generic name for a number in the sequence and we use either a sub n or u sub n. For example, we can say we want a sub 3 or u sub 3, which are both referring back to that third number in the sequence. So a sub 3 means I'm looking at the third one. U sub 3 means I'm looking at the third one. And we use the A or the U depending on what kind of equation we're talking about. The A sub 3 is with an explicit equation, which means we're talking about y equals. And the U sub 3 is talking about something called a recursive equation. And we're going to learn more about that in our lesson today. In this recursive formula that we're going to be talking about, our recursive equation, the next answer depends on the previous one. Example. Start at 5 and add 2 each time. In that example, my first number would be 5 in my sequence. The next number would be 7, then 9, then 11, so on and so forth. That's called a recursive situation. And we're going to talk about how to do that. In an arithmetic sequence, that's where you either add or subtract a number each time. And the common difference is the number you add or subtract to get the next number. So the example I gave in purple, where we started at 5 and we were adding 2 to get to the next number, what we would say is the common difference is 2 because we're adding 2 each time to get to the next number. That's called the common difference. Usually they use the letter D for that. Bless you. In a geometric sequence, we have the number you multiply or divide by to get the next number. Usually, in our class, I'm going to focus on multiplying because I find that that's usually easier for most people to work with in the calculators when we write down these recursive equations. So I'm going to focus on the multiplying. And then the last thing in our vocabulary is what is the common ratio. They use the letter R to talk about this common ratio. And the common ratio is the number we multiply or divide by. So for example, if I said, let's start with the 5, but this time let's multiply by 2 each time. So I would go 5, and then the R would be 2. I'd multiply by 2 and I get 10. I'd multiply by 2 and I get 20. I'd multiply by 2 and I get 40, so on and so forth. The difference between arithmetic sequences and geometric sequences is when you're adding, when you're multiplying. Okay, so adding and subtracting are actually the same operation. For example, I could add 2, or I could add the opposite of 2. Geometric is multiplying, and multiplying and dividing are really the same operation, just looked at a different way. For example, I could divide by 3, or I could multiply by 1/3. Same thing. So that's why I'll focus on multiplying in the second part. Okay, let's try an example. First example, a rectangular table at a restaurant will seat 6 people. 2 tables pushed together seat 10. Fill in the chart to see how many can be seated at the following number of tables. Okay, so number 1. First of all, if we know that 1 table can seat 6 and 2 tables can seat 10, how many are 3 going to seat? How many?
14.
14 is correct. Good job. And then 4?
18.
18. And it keeps on going. So how would I find 10? Keep going. Okay, so I'm going to give you 60 seconds. See if you can find out how many for 10. And this is a chapter where you're going to want your calculator. Some chapters we don't really need them, like when we get to a lot of the algebra stuff. Not necessary. This is really a good chapter to have your calculator. No. You might want to pull out your calculator.
$42.
42 is correct. Who said that? Voshan, was you? Yeah. Good job, Voshan. That's 42. Just keep adding. Start with 6. Go +4 on your calculator. Enter. plus 4, enter. And if you keep hitting enter, once you've done it twice, your calculator will store the fact that you've been adding 4, and it'll just keep going for you. Now this is a good way to find the answer. I'm going to show you a much better way, because what if they said 1,000 tables? That's going to be kind of annoying to hit that button 1,000 times. So we find that's what math people do, is they find ways to make things more efficient. Sometimes just doing a quick enter, enter, enter on your calculator is the most efficient. Use that way. Sometimes an equation is much better. How many tables do you need to seat 15 then? Or to seat 62, excuse me. 250? No.
15.
15 is correct. Very good. 15 tables is all you would need to seat 52. So again, you can use your calculator. See how many times you had put on an extra table. So the first time you have 1 table, 2 tables. Already at 10, we have 42 people. I only need 20 more people. Now we want to write a recursive rule. This is kind of what the whole idea is in this section. So what I want to tell you is, in recursion, there are 2 things that you have to have. The first thing is where you start. So we're going to say that the first number, which we're going to call u sub 1. Now when I say the u means that I'm talking about a recursive equation. And I'm going to show you how to do this in your calculator later. So u sub 1 means recursive, and 1 means it's the first number I'm talking about. So I put that down as 6, because I started with 6 people. And then the second thing, which is kind of a weird looking thing, goes like this. U sub n. If you recall earlier in our notes, we talked about that u sub n. Now the sub means it's a little letter that's below to the right, not next to. It doesn't look like un. It's u with a little n next to it. U sub n means I want the general term. Like what if I was talking about the 100th table or the 21st table? I don't know yet. So since I don't know, I put an n. And when I do know, then I'll plug that in. So if I'm going to do that, I want the previous table. So for example, if I want to know how many are going to seat at 3 tables, I need to start with 2 tables and then do something to it. So if I have n, then the one that came before it is called n minus 1. And later on, if you want to see why that is, I can show you. The big idea, though, is that you know it's the previous or the previous number. And then what are you doing to this previous number? Well, I'm adding 4 each time. So the u sub n is what's happening next. The u sub n minus 1 is what's happening right now. And then the plus 4 is what do I do? Or in other words, what's the difference? And we're going to do this in our calculator shortly. So you can see an easy way to type this in so you don't have to actually go plus 4, enter, plus 4, enter, plus 4, enter.